Good day viewers, my name is Audrey Polton. Welcome to lesson 4 for grade 10 and 11 mathematics. The topic for today is using the law of indices to do division. Let's have a look at the objectives of the lesson. By the end of today's lesson, you should be able to use the law of indices to do division. Let's consider division in algebra. For example, x to the power of 7 divided by x to the power of 3, which can be written as the fraction x to the power of 7 over x to the power of 3. To understand the process, let's first write the numerator and denominator in expanded form. Remember that any value divided by itself is equal to 1. We can cancel 3 of the x factors on the top with the 3 x factors at the bottom, leaving 4 uncancelled x factors. This leaves x to the power of 4 as the final answer. Do you notice that 7 minus 3 leaves 4? As long as the bases are the same, subtracting the indices gives the answer to a division. In the example, x to the power of 10 divided by x to the power of 5, be careful not to make the common error of dividing the 10 by the 5. These values are indices, and indices have their own laws. To explain the process, let's expand to show all the x factors. Again, do you notice that the indices have been subtracted? 10 minus 5 gives 5. This is because the 5 x factors in the denominator cancel with 5 of the x factors in the numerator, leaving 5 uncancelled x factors written as x to the power of 5. The difference between the index in the numerator and the index in the denominator is 5. This allows us to state the law of dividing in algebra. If the bases are the same and you are dividing, subtract the indices of the same bases. Now you can practice using this law to simplify the examples shown. Number 1. X to the power of 9 divided by x to the power of 5 is equal to x to the power of 9 minus 5, and that is equal to x to the power of 4. Number 2, x to the power of 5 divided by x to the power of 2 is equal to x to the power of 5 minus 2, and that is equal to x to the power of 3. Number 3, x to the power of 6 divided by x is equal to x to the power of 6 minus 1, and it's equal to x to the power of 5. Number 4, x to the power of 3 divided to x to the power of 2 is equal to x to the power of 3 minus 2, and it's equal to x. Now something new. What would you do with this example? X to the power of 5 divided by x to the power of 5. There are two ways to work this out. The first is the method we have seen before. Any value divided by itself is equal to 1. The second method is using our law of indices for division. But before we do that, there is another rule in math which we need to learn. A number to the power of 0 is equal to 1. This applies to any number except for 0. 0 to the power of 0 is undefined. Let's simplify x to the power of 5 divided by x to the power of 5. A second way. This time by subtracting the indices. The base is x, Subtract the indices. 5 minus 5 gives 0. Now, using the new rule we have just learned, we know that x to the power of 0 is equal to 1. So whether we simplify by cancelling or by subtracting the indices, we get the same answer of 1. This will be true for any fraction where the base and index in the numerator is the same as the base and index in the denominator. When you are dividing in algebra, as long as the bases are the same, you can subtract the indices. Up to now, the bigger index has been in the numerator. Secondly, if the bases and indices are the same, the answer will be 1. Make sure you understand these two basic concepts. The examples on the screen show the two concepts. Y to the power of 3 divided by y to the power of 3 is equal to y to the power of 3 minus 3. And that is equal to y to the power of 0, and it's equal to 1. P to the power of 8 divided by p to the power of 8 is equal to 1. Recap. Dividing in algebra, subtract the indices. X to the power of 8 divided by x to the power of 6 is equal to x to the power of 2. X to the power of 7 divided by x to the power of 7 is equal to 1. Now let's look at a different example. In the example, x to the power of 3 divided by x to the power of 5, we see that this time the index in the denominator is bigger than the index in the numerator. If we use the same law as we did before and subtract 3 minus 5, we end up with negative 2 as the index of x. Expanding factors as we did before will help to explain what to do. There are more factors of x at the bottom and fewer factors of x at the top. Cancel as we did before. This leaves two uncancelled factors of x in the denominator, so we have the fraction 1 over x squared. We can do the subtraction of 5 minus 3 in the denominator, but the answer of x squared is written in the denominator. Here, a few more examples are shown. Number 1. X to the power of 2 divided by x to the power of 8 is equal to 1 over x to the power of 8 minus 2. And is equal to 1 divided by x to the power of 6. Number 2. X to the power of 4 divided by x to the power of 7 is equal to 1 divided by x to the power of 7 minus 4. And that is equal to 1 divided by x to the power of 3. In each case, you can see that the subtraction is done as the bigger index minus the smaller index. The answer is written where the bigger index originally was in the fraction. Sometimes there are numbers as well as variables with indices. Divide the numbers as usual and then divide the variables as we have just learned to do. In example 1, first divide the numbers. 9 divided by 3 is 3. Subtract the indices of the x factors. 7 minus 5 is 2. The answer is 3x squared. In the next example, divide the numbers first. They form an improper fraction. 25 divided by 5 is 5. Now divide the variables by subtracting the indices of x. 7 minus 4 is 3. The answer is 5 multiplied by x cubed, or just 5x cubed. Here is another example. But this time the numbers form a proper fraction. Just simplify it as you have always done. The 4 in the numerator divides into the 12 in the denominator 3 times. Subtract the indices of the x factors. 8 minus 5 is 3. The final answer is x cubed over 3. Notice that the bigger index of x is in the numerator, so that is where the x cubed goes. The opposite happens in this next example. Simplify the proper fraction by 5 at the top and the bottom. 15 divided by 5 is 3 and 35 divided by 5 is 7, giving the simplified fraction as 3 over 7. Now do the variables. The index of x in the denominator is bigger than in the numerator. Subtract big minus small. So 11 minus 5 is 6, which is written as the index of x at the bottom. Remember that all of the x factors at the top cancel with those at the bottom. So there are no x factors left at the top. The invisible one from cancelling is multiplied by 3, and we only see the 3 in the answer. In the example you see on the screen now, the whole of the numerator can divide into the denominator. 6 over 18 is a proper fraction which simplifies by 6 at the top and bottom. 6 divided by 6 is 1 on top, and 6 divided into 18 3 times, written in the denominator as shown. The index of x in the denominator is bigger, so subtract as 9 minus 4 is 5. The entire numerator is cancelled, which is shown as 1 over 3x to the power of 5. We've come to the end of the lesson. Let's summarize what we have learned today. If the bases are the same and you are dividing, subtract the indices of the same bases. Viewers, we have come to the end of the lesson. Thank you for watching. Until next time, goodbye.